All right, let me give you just a few of the announcements. There are, I think I've told you this before, on my desk in my other classroom is a job announcement for No Child Hungry or something like that. They're looking for a brand representative or something like that. Okay? Thank you. Okay. After class, I've returned all papers for people. So after class, if you come pick up yours. I've returned the quizzes and tests. So if you come after class, I'll give you yours. Okay, because I don't want to take class time to do that. Go through all those again. Okay. So if anyone's interested, it's a brand representative. There's a job description. There's a company description. The salary is $375 a week. It sounds like something like that. You can see all that information. It came from one of our coaches. Is there a coach? Jefferson? Yes, okay. He's the one that sent the email to us, and he had Henry's name on it. I didn't give a last name. Probably started with an S, and he's the person who's doing this thing. So if you're interested in that, or if you know of anyone, sounds like a great sort of entry-level type job. So let me know. I've got the information there. There's another thing on my desk in there I want y'all to be aware of. Various universities they apply for National Science Foundation grants, and those that get them run these research experiences for undergraduates, REUs. And Amari participated in another grant that was the Thurgood Marshall. It's sort of like this, only this is a bigger thing. It's a 10-week summer thing. Not all of them are 10 weeks, but this one is at UAB. A fantastic experience to get some great, you learn so much. Don't you think you learned doing what you did? 10 weeks with really good people. They're helping you out. They're paying you to be there. They, I think, even provide food and lodging. I mean, it's a great deal. If you're interested, the form is on my desk. I think you can go to Blackboard and look for these kinds of things there, too. I don't know for sure, but I believe you can. All right. Now, finally, Monday, late Monday, I didn't know this until after class, they open student course evaluations. Have any of you done those already? Okay, great. How long did it take? Maybe 5 minutes. Okay, that's about what I hear from most people. Okay, it doesn't take long, but please do them. I'm a math department chair. I use the student course evaluations big time when I'm doing my annual evaluation of my instructors. So please do the student course evaluations, okay? Please. And you may also be asked to do one or two others like admissions, food service, maintenance, library, something like that. If you are, please do those too. They don't get as much feedback as we do, and I value yours, your student course evaluation, so I know they value what you do for them. So please do all those evaluations I asked of you. All right. Now, I think you have till the end of finals week to do them, but don't put them off, okay? Because I remember when I was an undergraduate, once I took that last final, it was like the old game Etch-a-Sketch, shake it, and I forgot everything about anything I was supposed to do after that. So please do them before you take off for Christmas, okay? All right, now let's talk about this class, okay? We have our final exam Tuesday morning. Now, I haven't seen the final exam schedule, but I've seen the others for the last several terms. Even though we went to 8:30 start times on classes, I think they still have finals starting at 8. Is that correct? I think so, too. So ours is technically Tuesday morning, 8 o'clock in this room. Now, I understand if y'all have schedules that you have to keep up and you can't make it then, get here as soon as you can. I'll be here, knock on wood, at 8, and we'll have the final starting at 8. If you can't get here till 8:30 or 45, or whatever time. Get here when you can. This room will be open after that, so you can continue. I don't have another exam after that, so you can continue and complete your exam. If you have another exam, you can get finished as much as you can, then come back in and finish. Okay? So, what will the exam be like? Well, I think I told you last time, there'll be one part that's your Chapter 3 test. As far as we get in Chapter 3, that'll be it. It's going to be very short, very easy, I think, if you've been paying attention. So that should be very easy to do. Okay? Now, after you finish that, then there'll be the comprehensive part. That will be just Chapters 1 and 2. So good things to use to study are the test and the quizzes I've returned to you. Not going to be the same questions, but they'll be similar type questions. There'll be 5 questions from Chapter 1, 5 from Chapter 2. A lot like the last test you just took, 10 questions, multiple parts, yes.
How many questions are in Chapter 3?
I don't know. It depends on how far we get. Usually only about 5 or 6, because we just aren't going to get that far, okay? So it should be a pretty good grade, okay? So that's going to be Tuesday, 8 to 9:50, 10 o'clock, however long it takes, all right? Let me give you my schedule after that, okay? The rest of the day Tuesday, from whenever y'all finish your exam until 3:15, I'll be in my office. My 11:30 class, they're having, it's a small class, upper level class, so they're doing a take home. They'll be returning them to my office. So I'll be in the office from whenever we finish here until 3:15. But at 3:15, we've got our last second mini-term physical science class. So I'll be down in 255 at 3:15. Now, I'll be returning all their work to them that day. They'll have their last lab and their last test. So I'm figuring we'll be there probably about 2 to 3 hours, maybe a little longer, something like that. After they're through, I'll be back in my office until 8 o'clock that night. So 3:15 until 6 or so, I'll be in the classroom until they finish, then I'll be in the office until 8. That's Tuesday. Wednesday, completely free, okay? So I'll be in my office from 8 in the morning till 6 in the evening. So you can, if you have any papers or other things you're turning in late, I'll be there then, okay? Thursday, I'll be on campus from 8 in the morning until 3. I'll be on campus at 3, but that's when that class has their final exam. It's not going to be a long final, so I doubt if they'll be there more than an hour, probably less. And after that, I'll be back in my office till 8 in the evening. Friday, and let me tell you this too. Friday of this week, like tomorrow, normally I'm on the Birmingham West Campus 8 to 12. Not tomorrow. I'll be there from 8 till 8:40 because I have a doctor's appointment at 9:20. Okay? It's my annual physical, which it was scheduled last spring. And then the doctor called, his office called and said, he's got to reschedule, he can't make it, Bob, something, he's out of town, something like that. It's been so long ago. I said, well, when can we reschedule? They said, October, November. I said, what? They had me down for a weekday. I said, no, I'd like a Friday. Oh, well, then it's going to be December. So this is my annual physical that is almost a biannual physical. I don't know how much he's going to do. I don't know if he's going to have any extra tests or blood work or stuff like that. If he does, I may not be back on campus at all because I'm supposed to leave at 12. And if I don't get through with them until 11:30, it's not going to make any sense to drive back to Birmingham campus. So I won't be going back. However, if it goes real quickly, say and ends by 10:20, let's say, then I do have time to get back to campus for another hour or so. Okay, that's tomorrow. Don't bank on me being there more than 8 to 8:40. I will be there then, but after that, I may or may not be back depending on how long the doctor's appointment takes. All right. The next Friday, I'll be on the Birmingham campus, 8 to 12. Actually, 8 till 3. But graduation is 1 to 3. So I'll be there 8 to 12, or as long as I can stay in the office before we have to go over for graduation. Are any of you graduating this term? You are, okay? I don't think there's any super quick schedule we have to have your grades in, but try to get everything into me by next Tuesday if you can, okay? Earlier if possible, but no later than next Tuesday, and take your test then. I should have your grades in plenty of time. Okay. Then, the following Monday, after finals week, after next week, grades are due in by noon on Monday, that Monday. So I will be here all day Monday from 8 till 6, okay? But the morning part, I'm going to be getting grades in. After that, I'll be getting ready for next term. So I will be here. If you don't have everything into me by noon on Monday, you're getting an incomplete, okay? Then when you get the stuff in, I'll change the incomplete to a letter grade. I'll be here Tuesday and Wednesday. We're required to be here Tuesday and Wednesday, but I don't know where I'll be. They used to let us work in our offices. I wish they would do that, but recently they started running meetings on those extra days. I guess they're trying to make sure we're going to be there, okay? I don't know. They haven't told us yet. So I'll either be on this campus in my office or over on the Birmingham campus in meetings, Tuesday and Wednesday. After Wednesday, nada here. No here anymore until the new year, okay? Any questions? All right. Whew. That was enough, wasn't it? Okay. Now, let's pick up where we left off last time. We're in Chapter 3, Exponential and Logarithmic Functions. So far, we're only talking about exponential. We've hinted at logarithmic, though you may not have realized it. Okay? But they don't give any examples past example 2. Let me make sure of that. Yeah. So, all right. Let's do example 5, page 201. 3.1 is exponential functions and their graphs. Example 5, let me get my pen set up. Sorry about that. Okay. And this one, by the way, is at larsonprecalculus.com. You can see an interactive version of this type of example. It says, describe the transformation of the graph of f of x is equal to 3 to the x that yields each graph. Okay? So I'm going to do my best rendition of f of x equal 3 to the x. You tell me, when x is equal to 0, what's f of x? X equals 0, what's f of x? 1. Very good. Okay, let me tick off a few points here. 1, 2, 3, 4, 5, 6, 7. Negative 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. When x equal 2, x equal 1, what is the value? 3. That's right there. When x equal 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. Somewhere up there. After that, it's off scale. How about x equal negative 1? 1/3. Negative 2. 1/9. Because it's 1 over 3 squared. Okay, which is 1/9. And negative 3 would be 1/27th. Okay, they're getting awfully close to 0. Okay, should run this here. Now, I'm not going to go through everything again, but I returned papers earlier, so if you'll pick them up after class. Okay, number 2, they have finally opened student course evaluations. Please do them. Okay. They just opened on late Monday, okay? I've been asking for weeks. Are they going to do student course evaluation? They finally opened on Monday, late Monday, okay? Number 3, your final exam will be in this room, 8 to 9:50 on Tuesday. But I can be here later if you need to. If you can't get here before 8, by 8, I'll be here. Okay? And if I'm not here, I'm in my office. The rest of it, you have to listen to YouTube video. Okay? Because I went in gory detail. So, from 1/27, which is awfully close to 0, the rest of them just get closer and closer to 0. Okay? So here's the graph of f of x, 3 to the x. That's a pretty ugly graph, but live with it. Okay. Now, they put another graph on here, and where did it go? There it goes. Okay. The second graph is this one. What color do you want the second one to be? Second? Pick a color. Huh? Orange. Aren't you glad? Okay. That we chose orange. Okay. There we got it. All right. This graph looks like this. Okay. The orange graph is just, okay. Okay, you ready for the second test? Mm-hmm. How about the first test? Mm-hmm. Okay. All right. What do you think the difference, the relationship between, those two graphs? What would be the function represented by that graph? What have we done? We shifted everything to the left 1 unit. What would do that for us? Anybody say? I'm sorry? X, okay. It's g of x is equal to 3 to the x plus 1. Because remember, everything you do with x seems backward. If you add 1 to it, that means you go 1 to the left. Okay. That was that one. This next one I can't draw on this graph because I didn't allow for it. Let's go to D part. The D part, give me a color for it. Blue. Okay, there's blue. And it's going to be right there. But then it's going to be right here. And then it's going to be right there. And then it's going to be here and here and here and so on. So here's the blue graph. What have we done to that one? So that reflected it across the y-axis. What does that? Say again? Negative x, okay? Because everything that was positive on x is now negative. So this one, I believe, was j of x is equal to 3 to the minus x. Okay, excellent. Now, I've got to redraw my graphs. Sorry about that. Okay, see you Tuesday, bright and early. Okay. So I'm going to have to redraw my graphs here. Let me go back to black to get this one drawn. What's that? It could be either way. Okay. So let me. Absolutely. For the Chapter 3 test, which is going to be very short, You can use the formula and equation sheet for that one. And then for the comprehensive final, you can either come up with a new one that covers chapters 1 and 2, or you can use the ones that you already formed for chapters 1 and 2. All right, so let's tick off a few points here. That means make them mad, okay? Okay. Okay. Now, go back to the original graph. 0, 1, 1, 3, 2, 9 is off scale. Negative 1, 1/3, 1/9, 1/27. So there's our original graph. All right. This one now looks like this. What color do we want this one to be? Red. Okay, this one looks like this. What have we done to that one? Reflected across X, so what would that one be? Let me go back. I'm sorry, I forgot to write down f of X. F of X is equal to 3 to the X, and this one is K of X, okay? K of X would be what? Negative 3 to the X. You negate the Y. The Y is your F of X, okay? So negate that, and you got the lower one. Same type things that we did with translations, reflections, stretches and shrinks, everything, just like before. You do it the same thing, but these are now your exponential functions. All right, good deal. There is a checkpoint. I highly recommend you do the checkpoints. All right. Now, the next subtopic here, a very important one, the natural base E. Now, you may say, why do we call that the natural base? I thought our natural base was base 10. Well, basically, we have a base 10. I think, this is my personal opinion, I think others share it, because we have 10 fingers, most of us do, okay? And that's why we do everything in base 10. When you ran out of fingers, then you just say, well, one more, and then start with your fingers again, okay? And then another one, okay. So that's how we kind of do that. But actually, the natural base of our number system is this irrational number, E. By the way, this was developed by a guy named Euler, and that's why he named it E. His name started with E, E-U-L-E-R. In many applications, the most convenient choice of a base is the irrational number. E is approximately equal to 2.718281828. Now that is a little confusing. You would think by looking at this, it continued repeating that 4 digits. It does not, okay? It does not. If it did, that would be an irrational number. It would be a rational number. If someone's got a calculator, and you can find the E to the X key, either press the key and press 1, or press 1 and press the key, whichever your calculator does, and you tell me how many digits you have. It starts with 2.718281828, E to the 1. Huh? Okay. Anyone got a calculator that goes any further? You do. What does yours say? Wait, just a second. I've got to get my pen back. I don't know. Okay. Say again. 4, 5, 9, 0, 4, 5. Hey, nothing is being repeated. That 1828 does not repeat past there. Just happenstance it does there. They keep going. Don't worry, the 4, 5 doesn't repeat either. Okay? It's irrational. Okay? Okay. Quiz 1 and quiz 2. Okay, you need the first test? Okay. These are grading. You need the first test. You need graph paper? All right. Now, because E is a number, just a number, we also treat it as a function, but it is a number, and it's a number about 2.7 approximately, okay? It means it's pretty close to 3. So its graph is going to look a lot like 3 to the x, and we just did that, okay? It's a little different, not much. 3 to the x was 0, 1, that's the same, and it was 1, 3, this is 1, 2.7, blah, 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 blah. And then 1 over that would be a little bit greater than 1/3. This would be a little bit greater than 1/9, and so on. So this is how your exponential function looks. F of x equal e to the x. That's your function, one of the greatest functions of all time. If you do continue to calculus, I hope some of you do, you'll learn to love the exponential function. It's wonderful. Okay? It's called the natural exponential function. That's approximately what its graph looks like. Very close to 3 to the x. Okay? Now, it says, be sure you see that for the exponential function, e to the x, e is just the constant. It's a number. Okay? With more digits. Okay? See, Amari, he can give them to you. Okay? Where x is the variable. Just like 3 to the x, 2 to the x, negative 7 to the x. I mean, whatever. No, you don't use a negative number for the base. Sorry. All right. So, let's move on to example 6. Use a calculator. And boy, for your test, please bring your calculators. You're going to have a hard time doing this stuff without a calculator. I would say next to impossible. Okay? And I don't have a stash of calculators. I have one little cheapy calculator that won't do exponentials. So I'm no good, okay? Bring your calculator. Know how to use your calculator. I can't, I mean, that's a bad time to try to learn to use a calculator during final exams, yeah.
I just want to say on our phones, on some of the phones,
Yeah.
like if you open your calculator phones like this, if you
Turn it. That will give you the big function. Does everybody know that? Okay, when you turn your phone, you get lots of functions, including E function. When you're straight up, I don't think it has the E function. Okay, so you can use your phones, but know how to use them. Okay, not to call in, what was that, when you had a bonus call or something like that, a show many years ago, I want to be a millionaire or something like that. You got to know, not that kind of use your phone. Okay. So, use a calculator to evaluate f of x equal e to the x for each of these values. So the first one would be e to the minus 2. You just plug in minus 2 for x. Now, okay, here's f of x is e to the x. X is equal to negative 2, so it'd be e to the minus 2. Okay? Now, my guess, that's going to be something a little bit greater than 1/9. About 11111, it's going to be a little bit greater than that.
0.135.
Okay, say a little slower. 0.125. 35. Oh, 35 here. Okay.
And then 33.
What was the last thing you said? 36 after the 3. 32 after the 35. 33 after the 35. Okay, she needs to learn to talk, don't you think? Okay, never mind. All right. My hearing's terrible. All right, that's about what I would expect it to be. Okay, how about negative 1? E to the minus 1. What would that be? 0.36, 7, 8, 9. Goodness, that almost sounds like a series. Okay, all right. Yes, it's a little bit greater than 1/3. 1/3 would be 0.333. Yep, that seems very reasonable. How about 0.25? E to the 0.25. What you reckon that one is? Oh, there we go. Sorry. Say that again. 1.28402, blah, 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 right? Now, why would that be the case? Okay? E to the point, yeah, it's greater than 0. E to the 0 is 1. 0.25 is a little bit greater than 1, so it's a little bit greater than 1.28402. How about e to the negative 0.3? What would that be? Should be a little bit greater than this. So I'm going to guess about 0.8 maybe. 0. What? 73, 74, 08, blah, 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 blah. Okay. Got it. Make sense? Okay. Now, again, you need to learn how to use your home calculator. This will give you your standard scientific calculators. Okay? Okay? Not the old kind, the newer kind. If it's f to the minus 2, e to the minus 2, this is how they suggest. You press the e to the x key. Now, you do not do a negative with the subtraction key, the one that's between addition and multiplication. Not that key. If you have a minus sign in parentheses, that's the negation key. Then hit 2 and then hit enter. Now, if you have an older scientific calculator, you may have to do your negative 2 and then hit e to the x. You have to know your own calculator. And on the older calculators, they don't have that key. They have a plus minus key. If you have a plus minus key, most of the time, you put the 2 first, then the plus minus key to make it minus 2, then the e to the x, and that takes e to that. But if you have nice modern calculators, I don't know how your phone does because you have different kinds of phones, but you get to know them, okay? And that gave us the 0.1353353, right? That Karen couldn't say very well, okay. All right. F of minus 1, same deal. E to the x, press that key, the negation key, 1, enter, and that gave us 0.3678, blah, blah, blah. A little bit greater than 1/3. That makes sense. 0.25, something a little bit greater than 1. A little bit greater than 0. E to the 0 is 1, so this is a little bit greater than 1. 1.28, blah, 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 blah. Okay? And then f of negative 0.3, it's not going to be quite as low as this one, so this value will be a little bit greater than that, and that's 0.74. Blah. Good deal. Make sense? All right. Get to know your calculators. There is a checkpoint. Do your checkpoints. All right. Now, the way I see people packing up, I'm guessing we've run out of time. So the chapter 3 part's not going to be very much. But, and this is not a bad thing to do, folks. If you want to just read ahead a little bit, do a few of those exercises, the homework exercises here, you could do any of the odds, 7 through 11. They're all at Calc Chat. 7's at Calc View. You could do, I would do all 4 of 13 through 16. The only answers in the back will be 13 and 15, and at Calc Chat as well. You can graph any of the odds, 17 to 23. They're all at Calc Chat. 17's at Calc View. We've run out of time for, no, we did the one-to-one property. Okay, sorry about that. 25 or 27, they're both at Calc Chat. 25's at Calc View. You can do any of the either 29 or 31, both at Calc Chat. 29's at Calc View. You can do any of the odds 33, either 33 or 35, they're both at Calc Chat. 35's at Calc View. Do either 37 or 39, both at Calc Chat. 37's at Calc View. And try doing any of the odds 41 or 43. They're both at Calc Chat. There you have to stop. However, the one-to-one property is just like it was for numerical basis. So you could probably do 45 or 47. Compound interest, we didn't get to do that, so that's going to be about the extent of what we do. Sorry we didn't get to logarithms. You can read ahead if you want to. Do some. Now, when you get your test, if there are questions on there, because I already made it out, I can't remember now how far we got. If the questions on there and say these are optional, if you know how to do those are bonus points for you. If you don't know how to do them, they don't count against you. We'll see. I can't remember how far I went. All right, any questions? Enjoyed having you in class. Looking forward to seeing you Tuesday morning, bright and early. And please, okay, 8 o'clock. Yeah, you'll be here on that. Okay. All right. If you can't get here at 8, get here as soon as you can. Please do your student course evaluation. Please. All right. You want to get your stuff, right?
What time do you leave today?
8 o'clock.